Hi all, welcome back. And in the last video, we understand asynchronous JavaScript with event loop. That was part one. Okay, in that we have seen what will happen, what's happening in the browser when we are using a set timeout. Okay, we have seen that. We have understand with the diagram. Okay, this is a JavaScript engine. This is a web API, microtask queue, and callback queue. Okay, we gone through some details with call stack, and if you attach any timer, it will go into the web API, and then once it is completed the delay, it will come to a callback queue, and we understand the importance of event loop. Okay, whenever um, the call stack is empty and if anything is there in the callback queue, this event loop will take that action. It will move these callbacks into the call stack and it will execute those things, right? If you didn't watch previous video, please go and watch and come back, otherwise it's very difficult to understand what at least we are talking in this video. Okay, and this video I'm going to show you practically what's happening inside the browser with the help of debugging the code. So I hope you are interested, right? So let's jump into the code. So here in the last session, in the end of the session, I just asked the question, what will happen if we give a delay of 0 milliseconds? Okay, we can see this in the next session. I'm just removing this because first we should understand how to debug the code and let's see what's happening in the browser. Then again, we can discuss a few more interesting details. This is a simple code. We have a console.log start and we have a set timeout, and we just has given a one callback function, and with a 5,000 milliseconds, that is equivalent to a 5 seconds, and simple console.log end. So we know that if it is a set timeout and we are expecting 5,000 milliseconds delay, so that first it will print start and it will set the timer in the browser and it will go and execute console.log end. After 5,000 milliseconds, that event loop will push this callback into the call stack. All these things happen. So let's see, we should do things we can learn through debugging. So that is going to be very important thing. So here for this program, this is the last line, right? Just observe that if console.log and end is executed, that is the last instruction in this JavaScript file. So after that, that call stack global execution context will be gone. So that's just remember that point. So here I'm doing small changes to this code so that it's going to be very helpful while debugging the code, because whenever you invoke this set timeout, it will return a timer ID. That is very important. So what I'm doing here, var, I'm just putting the timer ID. So I'm just taking the variable so that it will store the timer ID. Whenever you invoke this set timeout, it will return the timer ID into this variable. So if you are able to get that some timer ID, that is the proof that yes, it is attaching a timer in the web API. So I'm just printing that console.log, you know, so timer attached. Otherwise, we can say that simply the timer ID. So why we need to make it complex? Timer ID of that callback, and here just give something, and here just attach that timer ID. So if you are able to see some timer ID, that is a proof that yes, it is working absolutely perfect. So these are small changes, and one more small change is also there. So you need a little bit patience to understand these things because these are the complex concepts. But if you want, but after doing some debugging, it's going to be very easy. So instead of giving this like anonymous function, if you don't give any name for that function, it will show the anonymous in that call stack. So already global execution context is also came with anonymous name, right? So it, to avoid the confusion between whether it is a global execution context or the callback, I'm giving a name to this callback function. So we can't give a name for the global execution context, so that at least I'm giving a name to this callback function. So how to give a name for callback function? It's simple. Just go with the normal syntax. This is the arrow function syntax, right? If you give a normal function syntax, that's it. How to convert this into a normal function? So simple, just remove that arrow and just write down the function and give some name. Now what we can give, so I'm just giving name as love JavaScript. This is the function, simple. So this is also a callback function, but we are using a function statement syntax. Okay, this is not function expression or a arrow function. This is a very simple thing, basic things. Okay, that's fine. Our code is ready. Then we can go and see the browser. So I'm going to refresh this one and just do right click and do inspect, so that we can see the output. So let's see in the output console. Okay, already it's done. So I'm just going to refresh one more time so that you can see we got the timer ID. The timer ID is 1. You see, hope you are able to see. After 5000 milliseconds we got the output also. We love JavaScript. That means this end statement is logged in that console screen before that callback executed. Okay, that's what we have learned in the last session. So let's how to debug the code. So I hope you guys are already aware of that because you are watching my videos, if I'm not wrong. So if I put this video breakpoint here the first line and just refresh the code, what will happen whenever the JavaScript engine start executing, it will create a global execution context. So let's draw it draw it. So what it will do, it will create already a global execution context and it will start executing all lines of code. So fine, fantastic. And then we are executing the first line, console.log start. So once you execute this line, what will happen, you will see the message in the console, that is a start. So that is fine, we all understood easily. So I will just log the details, what are the things happening in the console here. So we got output as start. Fine, fantastic. So now go back to the browser and go to the sources. Okay, execution of line number 14 is completed. Now we are executing line number 16. What is there? We are invoking the set timeout, and what will happen? It will do two things. One thing is it will attach the timer in the web API in the browser, and it will return the timer ID, and that will store in that variable called timer ID. So let's see. So here first I will draw the diagram, what will happen, and we can see the same thing in the browser. So whenever you invoke that set timeout, what will happen? So it will create execution context for that, this small execution context, and immediately it will attach the timer and it will give that callback function. So which one we can see for use for callback functions? Let's take this. So this is our callback function. So we have attached this callback function to a timer, and what is the delay we have given? That is 5000 milliseconds. So immediately once it is attached, it will return one ID. It will return the ID. It will return one ID for us, and it will start counting down to 0. So 5000, 4999, like that. For each and every millisecond it will count down to 0. It is just traveling from 5000 to 0. That is happening in the background. So we'll get some ID in the background, right? That ID. So let's see that ID, and if you see in the browser, it will get logged into that. So whenever I invoke this set timeout, it's just action within fraction of seconds. So and that is gone already. So small execution context is gone. Okay, if you have confusion, don't worry about that small execution context. So it will create, actually it will create a small execution context, because once you come out of this set timeout, immediately it will remove that, because it is just hack. We are not able to debug that thing. That's why we are not able to see that execution context here. Don't worry. Now the actual thing. So let's see. Right now in the output we don't have anything. So still, so let's see, we have a timer ID or not. Yes, we got the timer ID. That means the timer is attached in the web API successfully, and it has written the timer ID. That ID is, the value of ID is 1. So now what we are doing, console.log, we are just going to log that timer. Fantastic. Just go to the console. So you are able to see that timer ID of callback function is 1. This is a proof, right? This is a proof whether it is attaching a timer or not, because if you are able to get some ID, that means it is successful. Successfully we are able to attach the timer in the web API. So then what will happen? Okay, once it is completed, so we have executed this line also. We got the output, and then it will go to the line number 22. It will execute this line, console.log end, right? it will it will execute console.log end, because once you complete that set timeout, already it is gone from this call stack. You can't see that actually practically gone. And what we have done, so the next step is going to execute this console.log, because this console.log is part of the global execution context, so that it will still, this global execution context is there. So now whenever you execute this console.log end, it will print. So here already it has done the timer ID. We got the ID as 1. Now it will print the output as end, because it is created. So in the source, just execute this line of code, and observe carefully. Still we have global execution context is there in the call stack, and once you execute this console.log end, it it will print end in the console. It will print end in the console, and it will remove this global execution context from the call stack. Okay, this also we can't see now actually in the debugging also, because it is just end of the JavaScript file. Once you move to the next step, immediately it will go into this line number 17, this callback event. So we can't see that actually. Few things we can't see. No, don't worry, but it will remove that global execution context. Okay, surely, trust me. Okay, now whenever I execute this one, what will happen? What will happen? You will see the output as end, and so here output is end, that is there, and in the diagram it will remove this, global execution context. Yes, it will remove this execution context. So you can say that, Raghu, we already executed this one. And here if you see, once you exit this script, then it will remove actually. Okay, but here if I execute this one also, okay, immediately within fraction of milliseconds, it is showing the love JavaScript callback function, right? That's why we can't see that at what time it has removed and at what time it has came. So but just follow this diagram. Now I will come to that point again. So I hope now, once after executing this console.log end, it will print end in the output, and it will remove global execution context from the call stack. That is also completed. And now what will happen after 5000 milliseconds? After 5000 milliseconds, okay, once the timer has expired, it will push this callback into callback queue or task queue. Okay, and this is very, very important. Now what is the role of event loop? Event loop need to check constantly whether the call stack is empty or not. If it is empty, and if anything is there in the callback queue, anything is there in the microtask queue, it will push those things into the call stack. Okay, right now, okay, so microtask queue, we'll come to that point later, maybe after 1 or 2 videos. So right now we just focus on this callback queue. So right now we have one thing in callback queue. Now here one surprising thing is there. So once your this event loop, once the call stack is empty, once the construct callback is empty, it will move this callback function into call stack. But here, whenever we are pushing this callback into the call stack, again our global execution context is also come. Yes. So if you see in the browser, if you see in the browser, because we reached that it is just trying to execute that callback function that is came, right? Love JavaScript is the callback function. Below that, you are able to see anonymous, right? This is a global execution context. And if you are able to see the global scope also, right? Global scope also. That means we have this global execution context in the call stack again. It will gone few seconds back. Once you complete this execution of this whole file, it will gone, and whenever you push the call back into the call stack, again it will come, because it's a god, because for whole JavaScript execution things, okay, global execution context is the very important thing. So it will come automatically, because that is a proof that you are able to see anonymous. This refers to the global execution context, and the scope of this anonymous is a global scope, right? Super fantastic. But I don't know, because still I have some small confusion that whether it really existed here or it will provide some reference here. Some sort of confusion is there for me also. But yeah, it is there because you are able to access a lot of things from the global execution context. Okay, it will be there because here it's clearly showing this global execution context, so we can trust that it is there. Okay, fine. Now, finally, our callback came into call stack. What is the name of that our callback? That is allow JavaScript, right? This execution context name is love JavaScript. Okay, and now we are going to execute the love JavaScript. What is there in the love JavaScript code? Simply, we have only one line, that is considered log, simple string, that is we love JavaScript. Then what will happen? Still in the console, in the browser console, we don't have that we love JavaScript, because still we didn't execute it. So now whenever you execute this line, what will happen? It will print, it will print, it will print we love JavaScript. We love JavaScript. Okay. After that, once it is printed, and again observe carefully, it will remove, once the job is done, it will remove this execution context also from the memory, and nothing, because we have only one callback, nothing is there, so that it will remove global execution context also, because yes, that's the procedure. Because after some time, if you got any other callback after 10,000 milliseconds or something, at the time whenever this event loop will push that callbacks into again call stack, at the time, indirectly or directly, our god global execution context will exist. It will come automatically along with this callbacks also. So that's what. So let's see what is there in the browser again. So please do debugging. Okay, just write the code and open that HTML file in the browser and put the breakpoint and start doing the debugging. Then only we will learn JavaScript. Otherwise, it's very difficult. Okay, I hope you are doing. So now we are at execution context of love JavaScript, and whenever you execute it, yes, we will get the output as we discussed. Yes, we love JavaScript. After that, and if you go to the next line, what will happen? If you go to the next line, that means the execution of that callback is done. Nothing is there in the JavaScript file also, because already we have done those things in the previous cycle. So what will happen? It will remove this love JavaScript callback function. At the same time, it will remove this global execution context also from the call stack, because it will clear the call stack completely. If you don't have anything, it will clear automatically. So maybe we can't see that, because again same, when I go to the next step, it will go to the some other screen. So if you see, it is going to some VM3517 something. Okay, and that callback is gone. still we are able to see global execution context, right? So right now don't worry, right now don't worry about that. Yes, it will remove that callback function, and after some steps it will remove that global execution context also. But unless until the browser, because we don't know, some few things are happening inside the browser, that's why still it is showing the global execution context, because we are just putting the breakpoint. If you remove the breakpoint, we can't see, we can't track these things. That's why it's very difficult that this at what time it is removing the global execution context and at what time it is pushing the global execution context is difficult, but this is happening in the browser. So hopefully you guys understood, right, what's happening in the browser for this callbacks, all this stuff. Understood? So just write down the same code, or whatever you want you can write down, and open that in the browser, put a breakpoint, debug it, and if you found something different, no problem, just let me know. If you found something, some mistake in from my explanation, don't worry, just at least suggest me what I did wrong, so that I will learn and again I can correct it. Okay, but hopefully up to my understanding this is definitely a correct thing, because I've learned from Akshay videos, and after that I did some other stuff, some by doing some practice. So this is my understanding. Okay, if you understand, please just put in the comment section that understood. If you didn't understand, okay, just tell me which one is difficult for you to understand, so that I will explain in detail in that section. Okay, that's all for today. And in the next video, I'm going to explain, we are going to take some complex example, because right now we have only one timer, right? So if we have a multiple timers, if we are dealing with a multiple callback functions, okay, how it will be? Suppose we are giving a 5000 milliseconds delay. We can create another timer with 2000 milliseconds delay. And the important thing is, if you give 0 milliseconds delay, what will happen? That is the very, very, very important thing. Okay, but of course, if I teach everything in a single video, definitely it will be boring. So that I want to I'm just splitting each and everything into multiple videos. So first part, we understand how it is working. Second part, we have seen how it is working by debugging the code. So in the next video, we can take few examples. We can create multiple timers and we can play with that. Okay, after that we can talk about the most important thing, another one, this microtask queue. Okay, and if you have if we have event listeners, right, how things will work, those things also we can learn. Okay, okay, that's all for this video, and see you in the next video. Bye bye.